Hello and welcome back to Waveform Science. I'm Jeff Hagan. Behind me we have another Bluetti. This one is the AC180. So this is an advanced prototype unit of the AC180. This unit has been floating around on various forums being discussed because Bluetti talked about and released the European version of this device before the US version. So there is some information floating around, but those are all on your European spec devices. At this point, by the time you get to see this video, the release has happened. Bluetti has announced it for the US by now. And then I can talk about the specs of it, which is exactly what we're going to do. So the AC180 itself puts Bluetti back in the game of making a mid-sized solar generator. This is a 1,000, or rather 1152 watt-hour unit. Half the size of an AC200 series, but bigger than the EB70S, their current mid-size unit. It has an 1800 watt inverter, so the inverter is large enough to run cooking appliances. Not for very long because the battery's not that big, but it can do it. So if you want to run a coffee maker, this can do the job. It has a larger solar controller than the smaller Bluettis, and a smaller solar controller than the bigger Bluettis. Decidedly mid-range. It also has all the newer features that you'd expect in their newer solar generators. No charging brick, built-in charging, multiple charging modes, app compatibility, all the good stuff. We're going to go through all of that. So first off, what's in the box? AC cable. Yay, no charging brick. I do not mind the death of the charging brick. You get a solar charge cable. That's in the box, and you get a car charging cable. That's in the box as well. Of course, you have the user manual, very important, and the AC180 itself. So let's spend some time. The next 2 days for me, roughly, to record this, and the next hour or so for you to watch it, and we'll go through all the specs. Now, I will call out, this prototype unit was sent to me by Bluetti actually a couple of months ago. It takes quite some time to do the efficiency diagram testing. This has been under active testing about a month and a half to 2 months before the recording of this video, because that's how long it takes to get the data. This is a prototype unit. This is not a retail unit. Bluetti sent me this for testing. I, at this point, don't even know if they want it back or not. They may. But I'm not paid by Bluetti to make these videos. They don't compensate me financially for this. And they don't have any control over the content of what's in this video. So this is pretty close to neutral. The real question is this a good device? And let's see if it is. First, let's take a look at the outside of the AC180 and the physical connectors. So we've got a solar input, 12 to 60 volts, 10 amps. Bigger than the other smaller Bluettis, but smaller than the AC200 series. Very reminiscent, actually, of the EB120, EB150, EB180, EB240, the lithium-ion standby machines that Bluetti sold for quite a while. That was before they switched over to the lithium iron phosphate batteries. Those machines took in 12-ish, I think it was 16 volts to 60 volts. On those, but this is 12 to 60 volts and 10 amps. DC outputs, we only have the one cigarette lighter port. The 5521 barrel jacks are gone. They're not there anymore. I guess Bluetti figured out that people weren't using them as much as Bluetti wants them to, so they have removed them. It's unfortunate for me because I'm one of the few that actually use them, but it is what it is. We do have a rubber grommet on the cigarette lighter port itself. We have a 100 watt USB-C port. We have 1, 2, 3, 4 USB-A ports. All 4 of them are 5 volt, 3 amp, old style ports. We do not have any quick charge ports on this device. We have 4 AC outlet plugs. They're all the same. These are NEMA 5-20 plugs. So you can see the T-shaped prong here. Your regular house outlets will plug into these just fine. But additionally, if you have a device that has a 20 amp plug on it, that will also plug into this port. Now, a 1800 watt inverter, if we were to take 1800 watts and divide it by 120 volts, to figure out how many amps we can have, that actually means it can output 15 amps. not 20 amps. So if you have a 20 amp device with a 20 amp plug, and it actually needs 20 amps, then this inverter probably isn't going to run it. But if you have a 20 amp device with a 20 amp plug and it doesn't really need 20 amps, there are a bunch of devices that are in that category. In that case, then it'll physically fit into this plug without needing to use a plug adapter, and may run depending on the power requirements of it. Okay, let's move on. Next side, we'll mess with the controls later. We have, as is becoming the standard these days, no power brick, just a computer input port. I really like this choice of plug for the AC input because these computer power cables are pretty ubiquitous. Wherever it is you go, there's probably a computer power plug in the same building as you. They've been using those things for, I don't know, gosh darn near 40 years. And they're everywhere. So if you forget to bring one, it's probably pretty easy to find it. So good on Bluetti for using a standard connector here. We've got a circuit breaker, just in case you blow it. We've got the grounding lug. We'll cover that later. We've got a fan on the back. Notice there is no light. There's no light bulb. There's no lamp. There's no blinking lights. The back of it is plain Jane. It's just got a sticker on the back. Interesting tidbit here, by the way. This is a 32 volt battery internally, not a 12 volt battery. So the 12 volt output is going to be running down from 32. The advantage of having a higher volt internal working load, though, is you can charge it faster, meaning that you have less amps because the volts are higher. And amps are the things that heat the device up. So you lose a little bit on the 12 volt output by having a higher battery voltage, but you gain a little bit as well by being able to charge faster. So that's a good thing. But we've got a sticker. It's got regulatory stuff on there too. Next side over, we have just a fan input. Nothing else on that side. Top of the device, we have a wireless charging pad. I'll show you that in a couple of minutes. Bottom of the device, we have rubber feet. I'm not going to show you the rubber feet. They're not that interesting to look at. So we've got 3 controls, just like the AC60. We've got a power button. Hit that and boot it up. It's going to turn itself on. Fan's going to spin up for a second. The fan turns on for a second or so every single time you turn it on. It's part of its power on. It does have a little icon that says the fan turns on. When you turn on the DC side, it says DC, and it also gives you a little wireless signal. The wireless signal is not Wi-Fi. The wireless signal means the wireless charging pad is turned on. So if the wireless charging pad is somehow broken, maybe the switch doesn't turn on, something like that, you'll have some notification that it's not working. But in this case, it is working, and we'll play with that later. AC side, push the button here. AC side turns on. That energizes the outlets. By the way, it takes about a second or so after you push the button. You'll hear it click in when the inverter is finally done turning on. It's actually a very good thing. It prevents your devices from getting partial power as the inverter starts itself up. So it does take a second. That's the controls. If you want to turn it off, it will turn off on its own if you just leave it be, if the AC and DC side are both off, or if it turns off automatically due to eco mode. We'll cover that in the app. Or you can press and hold, and it turns itself all the way off. How much does the AC180 weigh? We are looking at 35.1 pounds, which is actually a little bit less than the rated weight from the manufacturer. They say 37.4 pounds. The energy storage per pound is a little bit less dense than the older models, because the older models required an external charging brick, and those external charging bricks are not included in the weight. What are the physical dimensions of the AC180? Looks like about 13.5 by about 12.5. And I'm going to call that 9 3/4 right there. Official specs are up on the screen now. Energy density by volume on this unit is actually really good. It matches up with the AC200 Max. Of course, the AC200 Max's actual energy density is not including the volume of the power brick in this particular calculation, which means it's actually a little bit better than the AC200 Max. So good job on that one, Bluetti. Now we will compare some Bluetti devices side by side so that you can get a visual comparison of how large they are. EB3A versus AC180. EB3A, of course, much smaller. Next, moving up one size. EB55. Next to AC180. AC180 being more than double the size of the EB55. EB70S. It's a little bit wider, also a little bit squatter versus the AC180. Of course, the newcomer, AC60. AC60, by the way, is quite a bit thinner than the AC180. Show you that. There we go. Quite a bit thinner. Of course, the AC60 is also quite a bit smaller in battery size and inverter size. And of course, the comparison would not be complete without comparing to a relatively large one. So, one size up on the AC180 is the AC200 Max, which is quite a bit heavier, quite a bit larger, and quite a bit deeper. Charging modes. There are several ways to recharge the AC180. First, of course, there is a regular wall outlet. Plug that in. We'll start taking in some power. Similar to the EB3A and the AC60, there are 3 charging modes built into the app. There's a silent mode. That's going to charge at about 250-ish watts, plus or minus, measured from the wall. That's going to take 5 hours and 52 minutes, is what I measured, from 0 to full. There is normal mode, standard mode charging. Takes an hour and a half. And then there is turbo mode charging, which shaves about half an hour off of that and gets you right around an hour. I measured an hour and 8 minutes, but it does have that little, if you look in the graph, it has a little tail on the end of the graph there, where it's basically done charging and it's just finishing the job. So you can absolutely charge from those modes. How else can you charge? Well, of course, we have the solar input. But this particular solar input is actually quite handy. This is, and we'll cover in UPS mode why you might want to do that. But if you have a Bluetti T400 adapter, this would have come with an AC200 Max, or you can purchase it. You can plug that in, and it's compatible. This will charge off the wall at 400 watts from a T400 adapter. Okay? And again, we'll cover later why you'd want to do that. But you can. You can charge from a T500 adapter. It's the one with the fan. AC200P or AC200 Max comes with these. These also work for the B300, B230, and B300S batteries. Very common adapter for Bluetti devices. And this will charge it up at about 500 watts-ish once it gets going. And additionally, you can also charge this from the T200S. By the way, there are 2 versions of this adapter floating around. Some of the early versions, check the back sticker, are 47 volts. This is a 28 volt device. This is what comes with the EB55 and the EB70S. That will also work on this. And we'll charge at 200 watts. And again, we'll cover why we want to do that a little later. But there's multiple ways to AC charge this device. Solar charging. How does it handle solar panels? So what we have this hooked up to here, this is a 5,000 watt rated 33 amp DC power supply that goes from about 1.5 volts to about 150 volts. The DC input on here is 12 to 60 volts, so it's a lot smaller than what this power supply can put out. So this power supply right here, this will feed the AC180 as much power as it can drink. Let me go ahead and turn that on. And as we can see, nothing happens yet because the voltage isn't high enough. So let's give it a little bit more voltage. At about 10.5 volts, it turns on. It gives us a little solar icon. Fan turns on for a second, and then nothing. Why? Because 10.5 volts is below the rated charging rates. So let's get it up to a little bit over 11. There we go, at 11 volts. We're really not charging very fast. Okay. We're only pulling about, here's my current meter here, about 4 amps. So it's really not going to charge very fast yet. So 12 volts. 12 volts, I start hitting 8 amps of current, and it will hold the 8 amps of current for a while. Now, we're still only going at 90 watts. At 90 watts, this is estimating I've only got, 43% of the battery to fill, and it's saying it's going to take 6.4 hours to fill that 43% of the battery. So we're talking really 12-hour plus charge times from 12 volts. There is ways to get it to charge faster in a vehicle. We'll cover that in another video. But we're at 8 amps, 12 volts, so let's keep going up. 13 volts, 14 volts. So this would be your running car, roughly 100 watts or so. 15 volts, 16, 18 volts. This would be your basic solar panels. And notice it's still current limited to 8 amps. So even at 18 volts, it's not going to pull more than 8 amps, even if you have a 10 amp solar panel. If you have a 10 amp solar panel that puts out 18 volts, this is internally current limited. There is 33 amps available on this power supply. If the solar generator wanted to pull more, it absolutely could. But it's current limited at 8 amps at 18 volts. So let's keep going up. Get to about 24 volts. That's your higher end solar panels. 24 volts. And we are still current limited at 8 amps. So even with a single solar panel, so if I've got a single solar panel that's rated for 10 amps, and I plug it in, and it's a 24 volt panel, I'm only going to pull 8 of those 10 amps. Just that's how this device is designed. So let's keep going up. Because we got up to 60 volts, so we have quite a bit of headroom. 28, 29, 30, 32, and right there, 32 volts. Our current pegged up to 10 amps. So this is a 10 amp input, and it does actually pull 10 amps, but it does not pull 10 amps until you get to 32 volts. So if you've got a 20 amp solar, 20 volt solar panel, very common solar panel. In fact, Bluetti even sells them in this size, like a PV200. If you want to get the full 10 amps out of it, it's going to take 2 solar panels. It will charge off 1. Unlike, say, the AC200P that only charges off of 2 solar panels. This will absolutely charge off 1 solar panel. But it's only going to pull 8 amps on 1 solar panel. It takes 2 to pull 10 amps. Let's keep going up. 37, 38, 39. Notice it's still pulling 10 amps this whole time. Turn the screen back on here so you can see the charging wattage going up. 400 watts here. 42 volts, 43 volts, 44 volts. 45, and about 47 volts, 48, 49, and 50 volts. Now, right around 50 volts, it's going to max out the input at 500 watts. That's the most this is going to pull. So as I continue to bring the voltage up to the maximum voltage of 60 volts, it's going to reduce the amperage, which means that if you buy solar panels that when you put your solar array together, if you have between 50 and 60 volts as your working voltage, you don't need the full 10 amps because it won't pull that much anyway. So you'll see here as I keep turning the voltage up, see my current starting to go down. However, even though my current's going down, my charging wattage is still pegged at 500 watts. So you have this nice easy area here. And 60 volts is the rated maximum. So we're still pulling power here. However, once we get to, about 62 volts, it zeroes out. And when I tested it earlier, by the way, it actually zeroed out at 61. So here's what I tested earlier. You can see this bump right around 30 volts. That's where it decides to start pulling full voltage. And then you've got the nice flat area at the right-hand side of the graph. That's where it's easy. That's basically you've pegged out the machine, and you don't need full amperage. So anything over about 50 volts will peg out the machine. So now I've got it in overload mode here. It's blinking at me. Let's see if it auto resets. And it does. If I get it back in range, it resets itself and starts charging again. So if you have panels that are pretty close to the edge, and you get an event like a cloud edge type event where you get more light than you're expecting, and your panels put out too much voltage for a minute or so, the device will automatically reset the error. Now, if you go way over the rated voltage, and I don't know where the edge of the safe area is, but if you go way over the rated voltage, it is possible to damage this by overvolting it. So I wouldn't recommend trying to push the hard end of that envelope. But it is nice that it does reset. Next, can use solar charge and grid charge at the same time. So I've got this plugged into both an AC power and a DC power at the same time. Neither one has current going into it yet. So I can go ahead and turn on my AC power. It's going to wake up and start charging. Now the AC power, this is on normal or standard mode charging. So it's going to charge at about 1,000-ish watts. Depending on the temperature, of course. It'll slow it down if it's too hot. And now let me wait for it to get up to full speed there. There we go. That's about as fast as it's going to go. Now let me give it some solar and see if it goes any faster. A little bit faster, but not by much. So instead of pulling 1,050 watts, roughly is what it was pulling, now it's pulling 1,120 watts. It is preferring the solar. And by the way, with this voltage rating and this current rating, I am in fact maxing out the input with just solar. Here, I'll show you. I'll turn off the AC. Turn the light back on. So we're putting a full 500 watts of solar in here. So it does charge a little bit faster with dual charging, but it doesn't charge a whole lot faster with dual charging. There is one more way to recharge the battery in the AC180, other than simple wall charging and solar. It is sort of expandable in the same way that the AC200P is sort of expandable. This is a B230 battery. They also sell a B300 battery. Same idea, just a little bit bigger. These match up natively with the AC200 Max, and the B300 can match up with either the AC200 Max or the AC300. The battery itself has an output port right here, big giant output port, that you need a custom cable from Bluetti to plug anything into it. But Bluetti does sell this cable. I call this a P090D to DC7909, which DC7909 is the barrel jack that, by the way, is right there. And this is compatible. Let me demonstrate. Just plug this in. You got to hit the little lock, push the little locking tab in the lock position. If you forget to lock it, this whole thing doesn't work. So make sure you lock the cable. And the other end of this runs into the AC180. And then to get this to start charging, you have to press and hold. So I press and I keep holding until it blinks. There we go, now it starts blinking. Now, assuming that I have everything hooked up properly, this is going to boot up, and it's going to start charging at 500 watts. Now this is daisy chaining. So I'm charging one battery from another battery, which means I am going to lose power. About 30% of the power gets lost in this conversion process. But it means that this, which has 1 kilowatt hour battery in it, now sort of has a 3 kilowatt hour battery. That's actually pretty cool. Now, the downside is this cable's one direction only. You see it's running into the solar input over here. The solar input is never going to put power back out to this battery. So this battery is not going to recharge from here. So how would you recharge it? Well, of course, the battery, by the way, doesn't come with these. This is a T400 power brick. You can either sold these with the original AC200, or you can get it with the AC200P, or sometimes the Max, depends on exactly when you ordered it. The T400 is a 400 watt charger that does not have a fan in it. Or the T500 power brick. It's got Bluetti's name on it. This comes with either the AC200P or the AC200 Max. That's a 500 watt power brick. That does have a fan in it, which, by the way, stays on all the time. I kind of prefer the 400 watt one myself, just because there's no fan. Or the DC charging enhancer. This effectively gives you a solar input that can plug into this input, and I've covered that in another video. So those three charging bricks can then recharge this external battery. Now let's say you have a solar only setup. You don't have grid power and you want to use this battery to expand this device. How would I do it? I would get the DC charging enhancer, and I would plug my solar panels into that, and then the DC charging enhancer goes here. If I have grid power and I'm using it as a backup system, I would plug my grid power into the battery, and then, by the way, I would probably plug more grid power into the side of this thing, because you can charge them both at the same time. There's no problem there. Okay? But you can absolutely expand this with a B230 or a B300 battery. Now, the only downside is you only have one solar input. So once you plug the battery in, you can't plug more solar panels into this at the same time. But the nice thing about the compatibility here is the DC charging enhancer has the DC charging enhancer, which, by the way, takes in the solar input. This guy has exactly the same solar input range as the AC180. They're both the same. So if you build a solar panel array that works for an AC180, your solar panel array will also work for a DC charging enhancer, which means you can simply take the same panels, unplug them, plug them into a DC charging enhancer, and plug that into the battery, and then you can get 3 kilowatt hours instead of just 1. Pretty handy. Output port testing for the AC180. So we're going to start with the cigarette lighter port. This is 12 volts rated at 10 amps. The internal battery configuration here, by the way, is not 12 volts. It's having to down voltage it to 12 volts. So this is going to definitely be a regulated port. Let's turn it on and see what we get. So first you push the power button here. That boots the unit up. Then you push the DC button to turn on the output port. And you can see I'm pulling 8.5, 8 1/3 amps here. I'm getting 12.5 volts. Let's start pushing the power up, see where the end is. Now Bluetti tells me that on both the AC60 and the AC180, they've increased the headroom a little bit. So most cigarette lighter ports cut off between 8 and 10 amps. This one looks like I can get the full 10 amps. Now I did drop voltage a little bit, but that's because we're pushing the limits of this circuit, so that's actually kind of normal here. But we're running at the full 10 amps with kind of no problem. So let's keep going, see how high we can get. Some of your diesel heaters and whatnot need 10.5 amps to start up, so let's see if we can get that high. And it looks like we can. 10.5 amps. Let's keep going, see where the edges are. 10.7, turn the screen back on. 10.8. It's like right around 10.9 amps where it overloads. And if you do overload it, it's actually not that big of a deal. You can see it's blinking here. We've got the light blinking. You just push and hold. Got to hold it for a couple seconds here. It eventually turns back off. You got to take your load device and turn it back down so you don't overload it the moment it turns back on. And then turn it back on. And then you're back in business as normal. USB port testing. Let's make sure the port does what it's supposed to do. I've got the USB-C port plugged in my tester here. Let's turn it on. This is going to enumerate the port and determine that it can do what it's advertised to do. What you're seeing on the screen here, by the way, is all the different types of USB power transfer methods that this supports. Green stuff is what it supports, red stuff is what it doesn't support. So this is in fact a power delivery 3.0 PPS. That means it has selectable voltage, 100 watt port. So it's a 100 watt power delivery port. Very good. That's exactly what it should be. Now let's check one of the other USB ports. These are in fact all the same, and they are all marked as 5 volt 3 amp ports. So the only thing they should support is Apple's 5 watt 3 amp standard. It looks like in fact that is the only thing that it supports. So yes, in fact that is just a regular old 5 volt 3 amp port. Nothing else to it. Next test, we have our 100 watt USB-C port right here. Let's see if we can actually pull 100 watts from it. So I have a trigger adapter on this USB-C cable that's going to give me 20 volts. So we should see 20 volts in the tester when it's done turning on. And there we go, 20 volts. So let's see if we can get 100 watts. So that would be 5 amps at 20 volts. 3, 4, 4.5. Let's use the smaller knob. Now USB-C typically has a very hard cutoff right at 5 amps, so I don't want to push it much beyond that, but it should not let me go much. 4.99. Get to 5? I can get to 5, exactly 5. So I'm pulling 97 watts after the cable losses. 5.2 amps. Can I go any higher? 5.5. Oh, it's letting me go a little higher. So in fact, even the USB-C cable, 5.5 amps. Wow, that's way beyond spec. So yes, the USB-C cable, you can in fact pull the full rated wattage. In fact, you can pull quite a bit beyond, an extra 10% beyond. I don't really want to push this any further. USB-C circuits are not designed to be abused like this. But very good. Next, let's test the wireless charging pad. I have a wireless charging pad test device here. This device does not actually have any batteries in it. It just sits on the charging pad, powers itself, and tries to draw as much power as it can. I already have it set for the maximum power it can draw, which is 15 watts. Turn on the DC side. Get a bit of a closer look here so we can see what it's going to do. Position it right in the middle. And it passes. 15 watts. And of course, if it does 15 watts, it can always do the lesser ones as well. 7.5 watts is what an iPhone uses. Let's try that test just to demonstrate. We get just right. There we go. And of course, that passes as well. So wireless charging pad seems to work. Okay, AC output port test. So I've got a couple things going on here. First, I've got just a watt meter, just so you can tell the difference between what this one says and that one says. This is a total harmonic distortion meter. That's going to tell us how quality the power is. Lower numbers are better. Just to show you, this is the other end of that meter, and I'm going to plug that into my Pacific Gas and Electric utility power here. Show you what it says. We are at 6.7% harmonic distortion. Typically 5% or under is the target goal. Most devices work until about 8. So 6.7, that's what I get out of the wall, so that you guys have a reference point. Let's plug that in. And we'll say ready because it's not even turned on yet. So I'll turn this on. It's going to boot up. I'm going to give it some AC power. Meters all turn on. Very nice. And I am at 1.2% harmonic distortion right now. And let's kick on some loads here. So we got 1,000 watts of load going. This meter says 1,000 watts. So we're running at about 50% of the max load of the inverter right now. It's 1,800 watt inverter. I'm at about 1,000 watts. And my harmonic distortion meter is at 9%. Very nice. That's actually really, really impressive that it can do that. Now let's kick on some more load here. So we're at a little bit over the max output. We are still at 2% harmonic distortion. And 1689 watts, 1688 watts, yeah, about agrees with each other. So we're hovering about 80-90% of load here. Let's kick on some more load. See how high we can get. Now what I expect to happen is the harmonic distortion is going to kick up quite a bit when I start pushing it over the max load. And it does. 1900 watts. Nice. 2000 watts. Remember, there's an 1800 watt rated inverter. Already over the max limit here. 2100 watts. 2100 watts. That is, in fact, as high as this goes. Let's kick in some more power here. 2300, 2400, and there we go. Right around 2400 watts is when it kicks off. And same as before, if you do overload it, it's relatively easy to fix. Hold down the button for a few seconds until it stops blinking, and you can turn it back on again and you're back in power. But looks like we can push it up to about 2400 watts with nice, clean harmonic distortion. And for your enjoyment, I made a harmonic distortion graph across the various loads. Harmonic distortion does increase slightly as the loads go up within the bounds of the readings, but compared to the utility power, this is far cleaner power than anything you're going to get out of your utility. So very nice, very wonderfully clean inverter. Discharge efficiency tests. So one of the major time sinking tests that I do in these is I charge it up and discharge it, and charge it up and discharge it, and charge it up and discharge it many times, and I've done this enough so that I can compare these to other Bluetti products. So the discharge curve, let's first look at the EB70S, the AC180, and the AC200 Max. Pretty much all of these power stations, when they're used at very low wattage, have very low efficiency. That's because they have a standby wattage. And if the standby wattage is a very significant portion of the actual draw wattage, then you wind up with most of your power just going into standby. So the AC180, the efficiency there is 33%, which is a little bit less than the EB70S and a little bit more than the AC200 Max. Kind of expected. The larger inverters tend to have more power draw. So it's much closer to the AC200 Max's efficiency because the inverter size is much closer to the AC200 Max. Efficiency goes up from there. By the time you get to about 200-ish watts, the AC180 is actually the most efficient of the group, which is kind of neat. It has a little bit of a smaller inverter than the AC200 Max, so you gain a little bit of efficiency over the larger inverter, the AC200 Max. But it's not that much smaller. As you can see, the curve goes most of the way down. As a note on this graph, by the way, the EB70S could not complete the full drain. It overheated. That's no longer an issue with the newer Bluettis. They can, in fact, do a full drain 100% to 0% at maximum rated wattage. Take a look at the DC side of those same three units. The AC200 Max is the least efficient of the three. As we get into newer generation devices, things get a little better. The EB70S is better than the AC200 Max, and the AC180 is sort of in the middle between the two. EB70S is a much simpler device. It doesn't have Bluetooth. It doesn't have as much monitoring stuff built in. So it's going to wind up with a little bit better discharge efficiency. Also, notice the graph for the EB70S goes further over to 300 watts. Reason being, the EB70S has two USB-C ports. Each one is 100 watts, and then it's got a cigarette lighter output. This can put out a total of 200 watts, one USB-C and one cigarette lighter port. The EB70S can put out a total of 300 watts, so it's got a larger graph there. AC200 Max has the 30 amp 12 volt RV port. That can put out actually quite a bit more power. So that's where it compares in the lineup to units right next to it, let's instead compare the three newest models. So EB3A, AC60, and AC180 on AC discharge. Now, of course, these units are a very different size. In this graph, the AC180 is the largest of the three. And interestingly, the newest, and interestingly, above a certain level, the highest efficiency. AC60 has the highest efficiency between about 50 watts and about 150 watts. So if your load is in that range, you'd want to do the AC60 for most efficiency. If your load is usually above 150 watts, the AC180 is more efficient. It's larger, it has more mass, doesn't have to run the fans as hard. Makes sense. And if your load is smaller than what the AC60 does, in other words, 50 watts or less, then your EB3A tends to be the most efficient of the three, which again makes sense. Efficiency comes with size. Okay. DC side, same basic thing. Surprisingly, actually, on this case, the AC180 wound up in the middle between the two. The AC180 for a while there is in the middle, and it comes out on top at the higher end of the range, again because it's larger. So your AC60 is at the far right of the graph here. AC180 is at the top, AC60 is in the middle, EB3A is at the bottom. I kind of expect that. This sort of area in the middle where they're crossing over each other. That's an interesting artifact. I don't have a good explanation for that. It's probably an artifact of the testing. I would kind of expect them to maintain the same location in reference to each other all the way across. But, this is what the measurements showed. So I've got runtime numbers here as well, and these graphs will certainly be posted to the forum separately from this YouTube channel for people to be able to look at the runtimes of each device. So how much power does the AC180 use when it's just sitting there doing nothing? This is called standby power, and that's one of the things I've measured. There's an AC number and a DC number, but the short answer is not zero. They do use standby power. I've measured a number of Bluetti devices, and at this point I have enough data to actually compare them. So what we're looking at here is a graph of AC standby power. So I don't have tooling to measure it at 0 watts output. I have to put a load on it in order to get the tooling to even turn on, so it can measure when it runs out of power. So I put a very small load, 7.5 watts. And the assumption here is that any power that doesn't come out of the device is used internally, except for the power that's held in reserve. So Bluetti uses a 90% depth of discharge. That means 10% of the battery power is held in reserve. So 90% of it's available for your loads. So whatever percentage of it didn't come out of the device is used internally. And I'm not measuring what's going into the circuit board versus what's going into the controller versus what's going to the battery, because I'm not opening these. Basically, if it's used internally, it's used internally. So at very low standby power, the winner, of course, currently is the EB3A, followed by the PS70 one-time model and the AC60. Kind of as we'd expect, the EB3A and the AC60 being the current production models, and those being exactly where they need to be. And as you get larger in the scale of units, the efficiency goes down, which we would expect. Larger inverters tend to have higher standby power, and that's on the AC side. Now, if we look at the DC side is far more efficient on the smaller side of the scale. And additionally, the newer devices have a little bit less efficiency on DC versus the older devices, simply because they have to have a DC converter in them. EB55 and EB70S kind of win a little bit here, simply due to their simpler internal design. But then surprisingly, the next one after that is AC180 as the most efficient. More efficient than AC60 and slightly more efficient than EB3A. And all of those are more efficient than, say, the DC output on the B230 battery. And when you start to get into the larger units, like an expanded AC200 Max, your standby power goes up pretty high. So we're looking at, and I've got the wattages in the charts here, and these will be floating around on the forums after the videos are done. Sound level check. How much sound does the AC180 make? How loud is it? So first off, you can use the meter here to see how loud I'm talking. About 55 decibels for a normal conversational voice. Now, first I'm going to go ahead and give it some load. Turn the AC side on. .56 decibels, roughly. It's about medium fan. It's not screaming, but it is not zero noise either. It's still quieter than my conversational voice. Next, I'm going to give it some solar power at the same time, so we get the fans going any faster. There we go, now it's charging at full rate. Fans didn't turn on any higher. Okay, I've got it in turbo mode. Let's turn on the AC power as well. Now this is dual charging from both AC and DC, and putting out power. Reasonably quiet. Turn the AC back off. AC power input back off. You'll notice it gets a little louder when I turn that off. That's because it was in UPS mode a minute ago, where it wasn't actually having to run the internal inverter. 56 decibels. Very nice. Alright, let's go through Bluetti's mobile app. First we bring up the app itself. Assuming you're already logged in, you get these list of devices. This is everything that you own, or everything you've got registered in the app anyway. We're going to connect to the AC180, so we're going to hit the little Bluetooth icon. That brings up the main control screen for the AC180. We can turn the AC and DC outputs on and off. Hit AC and you'll see this light bulb that I have here is going to turn on. There we go. And if I hit DC, you'll see I'm drawing some power. If I hit DC, you'll see that my meter turns on and I draw some more power. So that can absolutely be controlled. By the way, new to this device and the AC60, there's a little Bluetooth icon right there in the corner. Screen turn back on, right there in the corner. That actually tells you that there's a Bluetooth device connected. Now I can turn the AC and the DC back off again. If I tap on the PV input, it tells me that there's nothing going on. There's actually nothing plugged in. But let's plug something in. See what it does here. So it should tell me, and it does, the voltage, and eventually when it starts charging, the current and the wattage that it's pulling from the solar input. And there we go, we're actually pulling some power here. Let's unplug that. And it does the same thing for the grid input. So I can tap on grid here, and I can see the grid input, and if I plug the cord in, it'll actually start charging here. See, it's picked up a frequency. Now it's going to pick up power and amperage. It's going to start pulling power from the grid to recharge the battery. Now what's not available, you'll see on the screen here there's a timer of how long it's going to take to finish charging. That information is not available in the app. So that's unfortunate. But let's unplug that. We don't need to make it charge anymore. Hit the little gear to go to the settings. We've got a device share device button. That's to allow other people to control your device via their app. Got charging mode. We can set it to standard, set it to silent, or set it to turbo. We've got, just like the AC60, we've got both a DC and an AC eco mode. So you can set how much power and how long until it shuts down. So if it's pulling less than 5 watts right now, it will shut down in 4 hours. And on the AC side, if it's pulling less than 15 watts, it will shut down in 4 hours. You can turn that on or off. We've got the power lifting mode that decreases the voltage to increase the amperage for certain purely resistive loads like heaters, water heaters, those types of things. Don't use that on anything that's got a motor in it or anything that's going to have a compressor in it or anything with sensitive electronics because it'll damage your electronics. We've got firmware update, which there shouldn't be one right now, but that's where you update your firmware. And then we've got the advanced setting menu, which similar to the AC60 has the grid enhancement mode, which we'll cover when we talk about the UPS. And we've got the output frequency, which should be set to 60 Hertz. Everybody set it to 60 Hertz if you're in the US. And then we've got a factory reset in case we want to reset it. Last thing for the mobile app is if you tap the very middle, it'll tell you the system status and the number of battery packs. This device is not expandable, so it's only ever going to have one. But if you tap on the battery pack, you can actually get some additional information. The serial number of your battery, whether or not there's a fault alarm, and the BMS version, which you can also see in the firmware screen. So that's Bluetti's app. Okay, next we're going to take a look at the grounding lug on the AC180. That is right here. And that may or may not come with the proper bolt in the retail unit. The demo unit that I have did not come with the bolt. And the size of the bolt is going to show up on the screen here right now. So first off, what is a grounding lug and why do I want such a thing? Ground tends to make your electrical devices less likely to shock you when they're running over long periods of time. For temporary generators, like the AC180, where you're not using it long term, ground isn't generally considered to be required, and many solar generators don't have them. However, if you're using them for longer term and or if you're using them for shorter term in a public setting, ground may either be a good idea or required depending on your jurisdiction. And when I mean required, if you're wiring up a cabin, you may be required to have ground. Your electrical codes may need it. If you're using it for a parade or a fair or some sort of venue, the venue may require that all generators are connected to ground, and the codes don't just really understand the difference between a gas generator and a solar generator. So they simply say all generators have to be connected to ground. So this allows you to actually do that. So that's what it's for. Let's make sure it's actually hooked up correctly. So first off, on this, I have this meter right over here. It says open. That's going to tell me if this lead is connected to this lead. When they touch, it'll make a beeping noise. There we go. So what should be connected is the ground lug right here. It's the bottom one on a standard US plug. Should be connected to the actual metal lug on the side of the device. So let's make sure they are. Here's one. That's good. Next one. Good. Next one. And the fourth one. Very nice. And they should be connected to each other. Very nice. Yep. So all four of these are connected to each other, and they're connected to the lug on the side, exactly what I would expect. The 12-volt DC side, cigarette lighter port here, this is not connected to ground. I'll demonstrate that right here. Here's the side of it and the ground lug, and then here's the back of it and the ground lug. I talked to Bluetti about this. The DC side of this solar generator is going to be a floating ground regardless of whether or not this ground lug is hooked up to anything or not. And I will call out one more thing specific to the prototype unit. By the way, Bluetti already said they're going to fix this. Is that in the prototype unit, this third pin of your power input is not connected to the ground lug. It will be in the production model. So they will have that fully wired up correctly in the production model. But you may have seen in some other review videos of the AC180 where they call out that that's not connected right. And they're right. It's not connected right. And it will be connected right in production. Bluetti tells me they already have that on their list of things to fix. So. Okay, UPS mode tests. There are effectively 2 UPS modes built into this device, similar to other Bluettis. The first one being pass-through charging, that we're actually going to cover second, and the second one being an offline UPS that we're going to cover first. The way an offline UPS works is when the power goes out, it very quickly switches to the battery. In other words, the AC input goes straight to the output, as long as there's no problems. When it detects that there's a problem, it switches that input from the AC to the inverter, and there is a switch time, non-zero switch time. So the first question is, how long is the switch time? So what I've got here is I've got a 9-volt adapter, and I've got an oscilloscope. The oscilloscope is going to measure when this adapter runs out of power, and it's going to pause at that time so we can see what it does. So let's focus in on the oscilloscope here. Oh, by the way, my battery is not fully charged. It's going to be doing this while charging because it doesn't matter. There we go. Okay, now we're focused in on the oscilloscope. We turn the power on, set the trigger. It's going to start charging. There we go, it's charging. And I'm going to cut the power here. Well, that's ugly looking. So we have this ugly looking graph here. So how long is that? That's the question. Luckily, we can measure this. Measure, cursor, type, time. A. Move A to about... that's pretty close right there. And B, about there-ish. So that was about 10.6 milliseconds right there. The standard is anything less than 20 milliseconds is good. Now, there will be some randomness in these measures. So I got 10.6 right here. But if I turn the power back off, set it back on to grid power again, reset the test again, I'm probably going to get a slightly different value because it really depends on exactly where in the sine wave the power cuts off. So let me cut it off again. See, this time I got actually a slightly longer time, but it's still in the 10s. It's definitely not up in the 20s. So we're in the 10 millisecond-ish range. Do one more just to make sure. Okay, we're charging again. And let's cut it off a third time. Wow, I'm getting lucky at stopping at exactly the same place. This time is a little longer, though. This one's good to actually measure. This one, at the end of that squiggle there, that's about 14 milliseconds. So it's a little bit longer than 10 milliseconds, but it's still definitely within range. So we're definitely within the 20 millisecond range. Another UPS-like mode that can be used with solar generators has been called pass-through charging. However, a more accurate name for this is really an online UPS, also known as a double conversion UPS. So in this setup here, I have the AC180 is charging off of a T400 power brick, and there's a little light here that we're going to see turn on a little later. The AC power comes in from the wall. It's turned into DC in the power brick. Then it's fed into the solar controller. The solar controller then charges the battery. The battery then powers the inverter. The inverter then feeds power out to my oscilloscope just as before. So what's happening here when the power is cut? Well, when the power is cut, the battery's charger stops charging the battery. That's it. The load is already running off the inverter, so in theory there should be no switch time. Now, the downside about this type of a UPS system is that you're always running off the battery, which means you're always cycling the battery, in theory. You're always putting load on the battery may always be getting cycles. But it does mean that your load is not going to lose power. So it's a little bit more of a reliable system. Your higher-end computer power supply type UPS systems tend to be a double conversion online unit. So I have my oscilloscope's in stop mode. This is what I'm seeing. I'm seeing my power brick here giving me some voltage, and I've got AC coming in. So this is going to trigger if I lose power. So right now nothing's plugged in. I'm running straight off the battery. So let me turn on my power brick here. You see a little green light. Just turned red. And now I'm going to start charging. And you'll notice my oscilloscope is still in green. It has not triggered yet. Let me manually trigger it, show you what it looks like. I still see an AC waveform. I still see power coming in my power brick. Go back into ready to trigger mode. So now it's charging. Let's say the power goes out. And if the power goes out, then the charger is going to stop. See? There we go. Charger's going to stop. Red light turned off. It's going to stop charging, but it didn't trigger. My loads never lost power. I turn the power back on. Again, my green light turns on. Starts charging again. It's going to turn red to charge. Maybe. Not really designed for me to cut and put in the power this quickly. But it will eventually start charging. But my loads still haven't lost power. So that's the critical bit there, is the loads are continuing to work even though. And just to show you that the scope actually does trigger if you really lose power. So I'm going to actually just unplug the charging brick. And there we go, it triggers right away. So plug that back in, set it back up, and I'll show you what happens if I turn off the AC. Same thing. If I just completely turn off the output, you can see the yellow, that's my AC waveform, just kind of goes to nothing, and my brick triggers. So if my loads did lose power, this would have triggered. But in the case of this type of setup, you actually don't wind up losing power even if the power fails. Now the downside is that you, of course, are putting more load on the battery. So the offline UPS mode is better most of the time in cases where power doesn't fail very often, and the load that you're powering isn't that critical if it loses power for a sub-second. But if you really need it to not lose power for sub-second, then you might want to consider using it in the online UPS mode. Some folks have attempted to use the smaller, the EB3A, as an online UPS. The challenge there is the thermals are a little bit too tight on that unit. You'll probably have better luck with the larger units like the AC180. One other thing about the online UPS, your average output load cannot be any greater than the power brick you're using to charge it. In this case, it is a 400 watt power brick. If I put a 600 watt load on this thing, the battery is going to go dead because it won't be able to charge fast enough. So that's another limitation of pass-through charging or online UPS mode. But it does both, and they both work. If you've gotten this far in the video, then congratulations. You've gotten to the end. I've run, I think, pretty much every test I can think of on this AC180 here, so now I'm hoping that we have a relatively good understanding of how this thing will behave under some relatively different kinds of use cases. So what it comes down to, what do I think of it? The AC180 is a device that Bluetti has needed for some time. They've had the EB70S, that's a 700 watt and 700 watt hour device. And then they have the AC200, which is a 2 kilowatt hour and 2 kilowatt inverter device with nothing in between. The AC180 it fills that hole pretty much. So it's for people that need a mid-sized device. You need to be able to run devices that pull a lot of power, potentially. Cooking devices, tools, things like that. Things that are bigger than what the EB70S can run. You don't need to run them for that long because you only have a 1 kilowatt hour battery as opposed to a 2 kilowatt hour battery. But you can pick up the device and move it around a lot easier than a device that weighs twice as much. So it's much more portable than the AC200 series. They did get a few things definitely right on this device. The solar input is bigger than their smaller devices. It's not quite as big as the AC200, but it can't be that big because they would have added more weight, and they can't handle the weight. So that's the entire point of this. They got rid of the charging brick. I love that. Only downsides. The DC side is very simple. There's a cigarette lighter port, and there's some USB ports, and that's it. There's nothing else to it. They are reserving the larger DC outputs for the larger devices. And it sort of is what it is. Added extra electronics and bigger DC side of things would make it way more. So it kind of is what it is there. It's got everything we expect, though. And it has a few extra features that we weren't expecting, like the ground lug and the 20 amp sockets are nice to have, even though it doesn't put out 20 amps. So, good device. All in all, it fills the niche that was needed quite well. And if you're looking for a mid-sized device, this is Bluetti's answer to that, at least for the foreseeable future. As always, I am not paid to make these videos. Bluetti did send me the prototype unit for me to do a review on, because it's not out yet. Otherwise, how would I have it? So other than the fact that they sent me their unit, I'm not paid to make these. They definitely don't have any control over the technical content of the review. They don't even honestly know which tests I'm going to run ahead of time. So it's pretty independent review of the device. And I do make my money in tech, but I make my money elsewhere in tech. I don't work in solar generators. I don't work in DC electronics at all. This is not what I'm paid to do. And it's not what I'm looking to get paid to do. I'm not going to be monetizing this channel. And in case you didn't see any ads, that's because I don't have it turned on. And I don't intend to. One last thing for this video. You do see I have got an AC60 and a B80 sitting over there. I don't yet have a B80 video because it's not done running the tests yet. It takes quite a bit of time to generate the testing for these devices, and it's not done yet. It will be out as soon as the testing is done. I don't have anything else that's preventing me from releasing it except for the fact that the testing isn't done yet. So it'll take the time it takes. As always, if you guys enjoy watching these, I will keep making them. So let me know in the comments or hit me up in the Facebook channels if you enjoy the videos, and have fun.